Hi, this is Dave Overman. I'm the Electricity Networks Director for GTC. SSEN kindly asked me to prepare this presentation around heat and the aspects that we're looking at and considering at the present time. As most of you will know, the housing standards for new build housing are changing, and that's bringing a lot of considerations to how we operate and how we deal with the electricity load. The good things is that thermal insulation levels are going up, which at the present time the industry is looking to have a 30% improvement in energy usage. And one of the areas that will also be impacted is the fact that the air source heat pumps are becoming more efficient and working better. The key thing to also think about, and it's something that tripped me up when I first started looking at air source heat pumps, is the fact that there's two power figures quoted. One is the input and one is the output, and of course the input one is the one that we're clearly interested in, more so in terms of electrical load, because that's where the electrical usage is going to be. The other things to think about is that over and above air source heat pumps, there are other solutions that could be looked at and are being looked at. Clearly, hydrogen is one of those, and government have got a policy to promote hydrogen usage long term, and some of you will probably be aware in Fife they're looking to convert one town to a hydrogen instead of gas usage town, and obviously as technology improve and the price of converting materials to hydrogen comes down, it will become a viable option, but that's longer term. The other thing that we're also seeing from time to time is ground source heat pumps, more so with larger buildings. So, for example, schools and sports facilities that are using ground source heat pumps, where they've got football pitches, etc., that can have the pipe work put into them to get the heat out of the ground. The other consideration, which is a downside for air source heat pumps, is the fact that the developers over the last few years have changed the boiler configurations such that you don't need a hot water tank. But obviously one of the things that has to be considered for air source heat pumps is that you need a hot water tank, or it's preferable to have one, in the fact that is then one of the stores to take the heat out of the air and put it into the hot water. An issue that we've come across, certainly in one of the DNO areas, is the proposal potentially to put three-phase solutions into new housing. And our concern with this is that, given the fact that everything is starting to reduce in terms of loads within brand new housing, the question would have to be, if a three-phase supply is needed in a brand new house that's going to have an air source heat pump and other appliances being used in it, then it'll make it more the case that the older properties that are converting to air source heat pumps, because those pumps will have to be bigger because the thermal efficiency of the properties aren't going to be as big, then there's going to be a significant increase in load in those properties, and certainly air source heat pumps will be more in the size of 10 to 12 kilowatts input, as opposed to the brand new houses, which are somewhere in the region of 4 to 6 kilowatts. So that's one of the areas to consider in terms of sizing of the air source heat pumps. There are a number of other considerations that need to be taken into account, particularly when looking at the new electrical heating loads going in. First one is substation sizes, so that's really important to consider twofold. One, converting from tier 1 to tier 2 transformers, which are obviously going to be taller, not necessarily wider, but in terms of what loading you need on your foundation, and ensuring that you get the right size building to put them in is going to be really important. Consideration of things like the reinforcement that might be needed and the timing of that. So talking to the DNO, making sure they understand what your phasing is. So as you build out, I guess the ultimate is from an LV supply to start with, moving through a 111 kV substation, and then ultimately onto a primary, and just making sure that you're not building the primary on day one, and allowing the DNO to manage their capacity as much as the IDNO as well. Ensuring that loads are balanced has always been a problem, and getting jointers to connect to the right phases so that you do get a good spread of connections across the different phases is really important. Similarly, as EV charging comes along, and understanding what the impact of those may be, having spare capacity in the substation could be a good solution, such that you can either bring out additional cables or have additional ways on the takeoff cabinet to ensure that you're future-proofed as the loads increase. Equally, we're seeing more and more developments now with PV installed, and we're starting to see a smattering of battery connections. So clearly, there's significant benefits in terms of the network and network design, but considering how it's going to work when the PV is going to be being operated, and also when the batteries will run out, and what load will manifest after that, is really important. The other key area that's for consideration at the moment is demand side management. Again, we're seeing more and more companies offering that as a solution. There's more equipment going into the house that can be controlled remotely, and all of that will be built into managing the network load, both for the low voltage network, but equally in terms of impacts on the high voltage side. So in terms of ADMD, what does this really mean? So I think the key thing for me is that we've had ADMDs at a certain point for a number of years. We're definitely seeing those reducing over certainly the last 10 years, with the development of LED lighting and the white goods within the properties becoming more efficient. So we've got this balance now of old load sort of being removed, new load in terms of air source heat pumps and EV coming in, but also PV and batteries coming in to support the property at the most local level. So do we see a large ADMD rise? Probably not. Do we see it going any smaller? Again, probably not. So I think from our point of view, we're looking at ADMDs above where we are now, but not significantly above. So that would be the takeaway for me, is that the heating revolution is making a difference, but it's not going to be a significant difference, whilst all the other developments are being compounded into improving the usage within the house. I hope that was of use, and if I look forward to discussing this with you and others in the near future.